Hello and greetings to everyone. We are to answer the following exercise. You'll see figure 1 above figure I. It's a circle which has a triangle within, and the question goes from figure I above. Calculate the following. A. The length of the arc AB. Remember, an arc is simply a portion of the circumference of a circle. We have to calculate this length from A to B. For question E, the length of an arc is calculated by making use of the formula. Divide the angle which is being subtended at the center by 360 degrees. We multiply by 2 pi radius over 1. It's the same as saying we divide the angle subtended at the center by 360 degrees. Then we multiply by pi times the diameter. Remember, 2r gives the diameter. That is another way of getting it. From the question, the angle subtended, this is the angle theta. It is 90 degrees. The radius is 5 centimeters from the center to any point on the circumference of the circle. We're going to write them down. Theta is 90 degrees and r is equal to 5 centimeters. This will give us the length of the arc AB to be equal to, we are going to divide 90 degrees by 360 degrees. We multiply by 2 pi. Remember, we are going to keep pi as pi. It remains a constant. Pi remains pi. We are not going to replace pi with 22/7. Always recall that 22/7 is an approximated value of pi. It is not pi. Times the radius, which is 5 centimeters. We divide by 1. You see, degrees will strike off degrees. 90 divided by 90 gives us 1. 360 divided by 90 gives us 4. 2 will go here 1 time, 2 will go into 4 2 times. We will simply be left with at the numerator 1 times 1 remains 1 times pi, which is a constant, it gives us pi. Pi times 5 centimeters gives us 5 pi centimeters all over. At the denominator we have 2 times 1, which is 2. Therefore means our length of the arc AB is 5 all over 2 pi centimeters. This is the arc length. We move now to question B. Question B is asking us to calculate the area of the minor sector AOB. Remember, a sector is simply that portion of a circle which is bounded by 2 radii and an arc. Minor, that means the smallest sector. Looking at this AOB, this portion like this, you can see these are the 2 radii and this is the arc. ABO like this is the major sector. So you take note of the difference of minor sector and major sector. Area of sector is given by, we are going to make use of this formula. We divide the angle which is obtained at the center by the radii by 360 degrees. Then we multiply the result by pi radius squared all over 1. Such. From the question, the angles obtained at the center by the radii is 90 degrees. The radius is 5 centimeters. This will give us the area of sector AOB, that is the minor sector, to be equal to, we are going to divide 90 degrees by 360 degrees times pi remains pi, times the radius squared 5 centimeters, all this squared over 1. This will be equal to, degrees will strike off degrees, 90 will go 1 time, 90 will go into 360 4 times. This will give us 1/4 times pi times 5 centimeters, all this squared gives us 25 centimeters squared all over 1. Such. Look at the numerator and the denominators, you see that we cannot perform any simplification again, so we just need to multiply. 1 times pi times 25 gives us 25 pi on the denominator. 4 times 1 gives 4. Then we attach centimeters squared. This is the area of the minor sector AOB. This area, this sector. Question C is asking us to find the area of the major segment AB. When we talk of a segment is simply a portion of a circle which is bounded by a chord and an arc. In this case, you see this is the line AB. The line AB is a chord. This is an arc. This is the minor segment AB, while this is the major segment AB. And for us to find the area of the major segment, this area, we are going to subtract the area of the minor segment from the area of the circle. Let us see. Area of major segment is equal to area of circle minus the area of minor segment. Such. Next, the area of minor segment is simply equal to, this is minor segment, you can see this. For us to get this area, it is the same as taking the area of the minor sector AOB minus the area of the triangle AOB. This is a triangle. Is equal to area of sector minus area of triangle AOB as such. This will simply be equal to the area of this, our minor sector AOB has already been calculated in question B. The area, which is 25 pi on 4 centimeters squared. We are going to insert it there. 25 pi on 4 centimeters squared minus the area of triangle. The area of the triangle in this case will be given by, we know the radius, the true length, and an angle between them. This will be a half r squared sine theta, where theta is the angle in between the two radii. This will be equal to 25 on 4 pi centimeters squared minus 1 on 2 times r squared, which is 5 centimeters squared, sine theta, which is the sine of 90 degrees. This will be equal to 25 over 4 pi centimeters squared minus a half times 5 centimeters squared gives us 25 centimeters squared times the sine of 90 degrees, which is 1. So this will be equal to 25 over 4 pi centimeters squared minus 25 on 2 centimeters squared. You will see that we can factor out 25 on 2. Take 25 on 2 times pi on 2 minus 1 as such centimeters squared. This will be the area of the minor segment. Knowing the area of the minor segment, we can calculate the area of the major segment. Now let's calculate the area of the circle. Area of circle is given by pi radius squared. This will simply be equal to pi times the radius, which is 5 centimeters, all the squared. This will give us pi times 25 centimeters squared. This will simply be equal to 25 pi centimeters squared. Now we can calculate the area of our major segment. Area of the major segment AB will simply be equal to, we are going to take the area of the circle, which is 25 pi centimeters squared, minus the area of the minor segment, which is we did the factorization, and we have 25 over 2 times pi over 2 minus 1, all this centimeters squared as such. This will simply be equal to 25 pi centimeters squared, if we expand, minus 25 all over 4 pi centimeters squared, negative 25 over 2 times negative 1 gives us, becomes positive 25 over 2 centimeters squared. You see that this and this, they are like terms, we can subtract them. 25 pi can be written as 25 pi over 1. The LCM of their denominators is simply 4. 4 divided by 1 gives 4. 4 times 25 gives us 100. Then we attach the pi centimeters squared minus 4 divided by 4 gives us 1 times 25 pi is 25 pi centimeters squared plus 25 all over 2 centimeters squared. This will be equal to 100 pi centimeters squared minus 25 pi centimeters squared gives us 75 pi centimeters squared on 4 plus 25 on 2 centimeters squared. This will simply be equal to, you'll see that we can factor out the 25 over 2. This will give us 25 on 2 times 3 on 2 pi plus 1, all this centimeters squared. So this will be the area of the measure segment AB of that our circle. We are done with the solution of the questions. If in case you have any worries, feel free to leave your questions at the comment section. Please like the video, share and subscribe to this channel. Thank you very much for watching.